recall last week we played with fire, right? Which means to say we're going into the thermal chapter this week as well. Anyways, the first thing we're going to learn today is basically how thermal expansion occurs. I'm sure everyone has heard about this before, right? Basically, heat expands and cold contracts, right? Everyone knows this, right? Heat expands and cold contracts. Why will heat expand and why will cold contract? It's due to the lattice vibration of a particle, guys. As you all know, if this is a solid particle, right? We can't say it doesn't have any movement, right? Because in reality, what happens is each and every one of these particles will be vibrating at a fixed position here, right? And because it vibrates through a fixed position, maybe it will occupy this amount of space, right? Today, what happens is if I start heating up, if I start heating up all these solid particles, I'm essentially pumping what into the atoms? What am I giving the atoms right now? If I start heating them up, very good. I'll be giving them heat energy. In other words, I'm giving them energy. And once I give them more and more energy, what's going to happen is they will start to vibrate at a larger space here, okay? They're going to start to vibrate more vigorously, right? And they'll vibrate, taking up a larger space. That's why we always say that heat expands and cold contracts. Well, the reason why heat expands is simply because the particles are vibrating at a much larger space. If you guys have ever been, I don't know if you guys did this when you guys were in primary school. Last time, the first encounter I had with heat expansion was in primary school where my teacher had a metal hoop, and a metal ball, right? So before she heated up the metal ball, she'll put the metal ball onto the hoop and it will go directly straight through it, right? Then after that, after she demonstrated that the ball can go through the hoop, she will take the ball and place it on top of the Bunsen burner. When she placed the metal ball on top of the Bunsen burner and heated up the ball, when she placed it on the hoop, it no longer can go through it. It will be stuck on top here. This was my first encounter of heat expansion and cold contracts. The reason why the metal ball cannot go through anymore is because the atoms inside is vibrating at a much larger space. And because they vibrate at a much larger space here, what happens is expansion occurs on. As you can see, before expansion is using this amount of space. After expansion is using this amount of space. Okay, so the first key thing that we learned today is heat expands and cold contracts. Okay, the next thing I want to ask you guys is which one do you think expands the most? Do you think solid, liquid, or gas expands the most? And why? You say something now. Solid, liquid, or gas expands the most, and why? Why? Why do you think solid expands the most? No, that's the wrong answer. In fact, if anything, solid particles will expand the least. Why? Because if you think about in terms of forces of attraction, guys, solid particles, the force of attraction is strong or weak? Strong. Because they are very strong, right? It means to say each and every one of these atoms here are being held together. They're held together by strong forces of attraction. Even if it tries to vibrate and break loose, right, it will only maybe like vibrate at a small, relatively larger space. But the forces of attraction is too strong, they cannot pull away. Compared to gas particles will look something like this, right? It'll be all over the place, right? In terms of their forces of attraction, how? Strong or weak? Weak. And because they have the weakest forces of attraction, gas particles actually expand the most. Because if, let's say, I start heating this up, right, you'll notice that it takes very little energy to break the forces of attraction apart. And thus, they will start pulling away further and further and further. A very common example that you can try later on is, you see all these thermal flasks, right? You put hot water inside. You put hot water inside and you close it very tightly. What you notice is, right, as soon as, after maybe like 5 minutes, you open it up again, right, you'll hear a popping sound come out. Have you guys experienced that before? Right. Why would there be a popping sound? It's because when you put the hot water, guys, let's imagine this is the thermal flask, right, and then you seal it up and then you put hot water inside here. What happens is, right, because this hot water, right, acts as the heat source, for these gas particles here. And what happens is it will actually directly heat up these gas particles, causing it to obviously expand further and giving more pressure into the container. And thus, as soon as you open it up, you hear the popping sound. It's because the energy was high enough, they collide against the walls more frequently, and basically the volume expanded inside out. That's why it pushed upwards. You guys get what I mean? Yeah, so glad for you to join us, Michael. Okay, so remember this in terms of expansion, solid will expand the what? The least, and gas will expand the most, because gas, the force of attraction for gas is the weakest. Okay, remember this, this is important. Building your basic needs. Okay, so if you look here, if you look here, very straightforward. When objects are heated, solid, liquids, or gas, they will gain thermal energy. As soon as they gain thermal energy, they will start to move about more, and their vibration takes up more space, causing them to expand in all different directions. Okay? The opposite is true as well. If the temperature falls, materials will get smaller and contract, because they are vibrating at a smaller space when it's cold, right? They don't have enough energy, so they vibrate at a much smaller space, right? Liquid expands more than solid, and gas expands more than liquid. Okay, get everybody? So what are the applications of heat expands and cold contracts? The applications of heat expand and cold contract is things that you see in your everyday life, starting off with the high tension cables. If you look outside your house, right, most of the time you'll see that the high tension cables are slanted. They're slanted in a way. They are never in a straight line like this. Why? Why do if let's say I'm an engineer, right, by right, a straight line like this is the shortest distance, and thus the cost of building this straight line is definitely more than building this, because by right this has a longer distance in terms of wire length, right? So why do I build it like this instead of this one straight line here? What will happen in a cold day and what will happen in a hot day? Or when it's raining. It gets smaller. Very good. When during a hot day like today, right, or for the past 2-3 weeks, what happens is, right, no problem, because we learned that heat expands. So on a hot day, right, the wire is just going to expand more and it will just slant even more only. No problem. But when it comes to the cold day, that is where the problem comes. Because I know that cold contracts, right? If cold contracts, it means to say, right, if I build it into a straight line, this cold contract is actually going to pull it even more. Right? It will pull it so much that eventually it will break. Yeah, it will break and snap. So then if it breaks and snap, then you have live wires here, which will electrocute the hell out of you, basically. Okay, so importantly, you'll notice that all the wires are always in a slanted manner, because I cannot build it straight. It would snap during a cold day, especially in places with winter, like Canada, UK. Hey, hi, welcome.
Hi, the count is
I'm so late.
jam.
Jam in the head, dog, thinking that this is the 5th week.
Yeah. Okay, I'm a clown now. Okay.
Not just you, don't worry. Him also, he also messaged me personally. So this is one of the applications. The second application is the tracks that you see on an MRT train or LRT. Right. You'll notice that engineers purposely leave a small little gap here. Why? Why do they leave a small little gap here?
Because something will happen if it expands. It will because if it expands, it will 凸上去啊，
Yeah, something we call buckling basically. Right. So on a cold day, no problem. It's just gonna contract and pull apart, right? Alright, shut up. It's gonna pull apart, right? But on a hot day, right, and then the train continuously roll against the tracks, right? It's gonna heat up, right? And when it heats up, it's gonna expand, so this thing is gonna push this way, and this thing is gonna push this way. If you push, still no problem, because there's gap until it pushes until there's no gap. when pushes until there is no gap, right, eventually what's going to happen is buckling is going to occur. One of it is going to go up to accommodate for the continuous expansion. And of course, if the buckling occurs in this kind of scenario here, when the train comes here, and then the train goes, which kills a lot of people. The last I've heard of a train derailing due to buckling because of the unforeseeable change in the temperature of the weather, right? I think it was Japan or Hong Kong, or maybe it was Japan. Don't know, I can't remember which country lah.
It's probably Japan.
I think 20 people died from this incident because the train just. Yeah, they tried to go Red Bull on them.
Yeah. If you pour Red Bull in the fuel source, you add wings to it.
Yeah, so this is what happens. And of course, the last and most common thing that you see is basically your airplanes. If you ever look at your airplanes, right, you'll notice that the wings which is not so simply illustrated, will have gaps in between the wings. If you guys ever take a window seat before, right? Why is there a gap in between there? Is simply because you know, it's going through very high velocities, right? And it's having friction against what in the air. When the plane flies through the air, what causes the friction? The air particle is very good, which is essentially air resistance. The air resistance constantly, have friction against the thing and then eventually burns up. Just like how a meteor will never hit the land and smash the ground, because as it enters the atmosphere, the air resistance will cause it to heat up so much that it will burn itself away to ashes.
Then how the dinosaur gonna hit by a meteor?
Oh, that was a huge meteor made by Jesus himself. Oh shit. Are you Christian?
He's Christian.
Don't complain to your mother. All of this is just a joke. Still, it's not. Don't complain to your mother.
Judgment Day.
Is among religious like just Christian not like the hardcore religious type
Hardcore religious is
I want to emphasize one against this. We have new faces here, guys. There's going to be a lot of dark jokes here. Some of the dark jokes will involve religion. Some will involve some private parts. Some will involve some swearing words, right? Some will involve race also. Don't you dare forget race. Right. So I want to emphasize that all this is just a joke. If you're not happy, you can just say, "Mom, I don't like the teacher. I don't want song anymore. Don't complain, okay?"
Gender
American now. Malaysia, the gender.
Actually, it's illegal to change your gender.
You know or not? Go to the Mahkamah Islam, they'll fucking still say you're a girl.
Yeah, I'm serious.
It's against the rules to be gay.
It welcome to like the.
But actually, in Christianity also it's not allowed to be gay, right? But recently, right, the Pope say can already. Did you guys read the news? The Pope say can black men already. Still not they can marry. Serious.
Yeah. But is it okay for me?
Yeah, they can already. Pope they say can bless them already. Yeah. Okay, anyways, anyone has any questions regards to thermal expansion? I'm not riled you guys up with some gay jokes already, but yeah. Anyway, back to physics. Okay, understand.
Is it okay, but just call?
Yes, copy. This will be a very good time to start copying real quick. Where's your books? Yeah, why are you not copying? I'm just gonna store it in my phone and forget about it later on. Good.
No, I have good mindset. Good mindset.
Good.
I have insane mindset.
Good.
Is not bad.
Okay. Everyone okay? Moving on to the next part, which is the proof that expansion of solid is less than liquid. Okay. So everyone knows how a thermometer works, right? You all know how a thermometer works, right? Basically, imagine today I have hot water, right? I have hot water here, and I place a thermometer that conveniently looks like something else into the hot water. What's going to happen? What's gonna happen as I place the thermometer? Let's say initially the thermometer reads 24 degrees Celsius. If I place it in hot water, what's gonna immediately happen?
The hot water will make raise the temperature of the thermometer.
Okay.
And then the mercury will expand into the temperature.
Okay. This will tell me this as the common answer, which is not wrong, but it's not exactly correct. A lot of students will think that, oh, the heat will expand the mercury up first and then eventually it will reach like maybe 100 degrees Celsius, right? Like that, right? But did you guys know that actually as soon as I place the thermometer into the hot water, the thermometer actually drops by 1 degree Celsius? Then only it will shoot up all the way to 100 degrees Celsius. My question is, why does it drop? Why?
The thermometer getting bigger.
Yeah, because Jesus blessed the thermometer. When in the book or not, the gay people can be blessed though. The gay news is cloned from Valorant.
Anyone get up? Why does it drop?
Is it because the thermometer gets bigger?
Very good answer. Very logical. A very logical answer. So what happens is, usually as I place the thermometer into the hot water, right? The first thing, put your damn phone away. The first thing that happens is that the thermometer actually expands because once again, heat expands, right? And the first thing that comes in contact with the hot water is actually the glass thermometer first, right? And it will expand. Because the glass thermometer expand, the liquid inside drops a little bit, right? But as soon as the heat penetrate, how's it going?
Penetrate.
As soon as the heat penetrate through the glass pulper, right, and reach the mercury or the alcohol here, right, what happens is because this is a liquid right, and because it's a liquid, it will expand more than the solid. That's why you can see that the temperature rises from the drop to all the way to the up. It's 100 degrees Celsius. Everyone understand what I'm talking about? Sure.
100% assumption rate.
100%. So if you look here, right, if you look at the notes here, initially the indicator drops because the round conical flask expands when heated. That's the first thing. Then after that, the heat reaches the red ink, means to say the heat penetrates through the glass already, causing it to expand. The red ink, which is alcohol, right? The indicator continues to rise as the expansion of red ink is higher than the expansion of solid. By the way, guys, fun fact, you know the thermometers, the liquid inside will always only come in two colors, red and silver. Why red and silver?
Red is alcohol, silver is mercury.
Very good. Mercury is the silver color that you see in the thermometer. Red is the alcohol that you see in the thermometer. It's red not because alcohol is red in color. It's not red wine.
Color dye,
right? It's a color dye. Very good.
I wonder how it tastes like.
Break it and break it next time.
That's
It's either fun color like green or purple.
Because red is the most eye-catching color and the easiest to measure against the scales.
I think purple is more eye-catching though.
Purple is the least eye-catching.
I don't know.
Red, there's a reason why the ambulance is red in color, right? Not purple in color, that's iron.
Oh yeah, purple is like gay flag. It's not eye-catching anymore. It's disgusting. I'm pretty sure one of like the LGBTQ flags is like purple color. Okay, it's disgusting.
The flag is rainbow.
Ew. Okay, that one. Get this purple outside. Ugh.
Okay, anyways, moving on to the next part, which is more related to the heat we played with last week, right? Basically, for those who did not come. For those who did not come last week, we were playing with fire and basically how come we did not, okay, for those who didn't come last week, let me explain what happened, okay? Last week we had.
I think you show video example instead. Show video example instead.
My video example.
To show the one where he threw the fire in the bucket.
I
Where is it? Wait.
actually I think I have it on my phone. Tell me to Android drop it to you. I have it on my phone now.
Oh, shit, yay.
Yeah.
Wait, for those who did not know what happened.
This happened.
Oh, yeah, we were playing with fire. Right?
Oh, bucket dog.
Yeah, so we will basically play with fire.
This is
And this is absolutely safe as long as you don't exceed the amount of gas that you put on your hand, lah, right? Why? Because before doing this, we had to soak our hands into water, right? And then we had to form a layer of protection of water. Then after that, we scooped this thing here is basically the butane gas, guys, which is flammable, that is trapped in the soap water, and then we just light it up with fire, and then it will just start burning, as you can see here. Right. So why was it important to cover our hands with a layer of water first? Is because water has a very high specific capacity. So what is specific capacity there? Today we'll talk more about it right now. Okay. So specific. People soap water.
So water because it contain the breathing bubbles now.
Why does my light keep changing?
What do you mean?
Keeps dimming. Anyways, today what is specific capacity? Specific capacity, by the very definition itself, is the amount of energy needed to change 1 kg of a substance by 1 degree Celsius. Sounds complicated, right? Let's look at the realistic example. Today, let's imagine I have 1 kg of water here. And then I have 1 kg of aluminium here. Okay. Different materials will have different specific capacities. For example, water has a specific capacity of 4,200 joules per kg degree Celsius, whereas aluminium has a specific capacity of 900 joules per kg degree Celsius. Okay. Now I want you guys to learn to look at the units and tell me the story of what's happening here. Okay, everyone look at these units and tell me what can you derive from 900 joules per kg degree Celsius? What does this mean?
Fire has less heat to burn.
Good. Which one requires less heat to heat up? Aluminium. Why? In terms of the number. Right, very good. That's a very good observation. If you were to look between the units, aluminium, if you think about it logically, aluminium is a metal, right? Metal are usually very easy to heat up. You place it onto a fire, within 2 or 3 seconds, the thing will start to heat up already. It will be so hot that you usually cannot touch it. But if you place a cup of water on top of the fire, right, you have to place for a damn long time before it can actually start heating it up. Why? Because aluminium, right, is a metal. Metal has generally lower specific heat capacity. Meaning to say, right, I only need 900 joules of energy to raise 1 kg of aluminium by 1 degree Celsius. So how is that applicable? Let's imagine today, right, I put both of these things into the same hot pot. Right, like a pot, and I put 1 kg of water and 1 kg of aluminium on both sides, right? This fire that I provide, right, I set it to be specifically only supplying 9,000 joules of heat. Okay, this fire that I supply is very specific. I only supply 9,000 joules of heat. Assuming that both of them start off at 24 degrees Celsius, how much would aluminium be at the end of the day, and how much would water be at the end of the day?
Water will be 26, aluminium would be 34.
Good. Water at the end of the day would end up at somewhere around 26 degrees Celsius, whereas aluminium will be somewhere around 34 degrees Celsius. Right. Why? Because if I have 9,000 joules here, right, I can change this aluminium by 10 degrees Celsius as long as it's 1 kg. Whereas this one here, right, because I need 4,200 joules to increase the temperature by 1 degree Celsius. So at the end of the day, I can only make it from 24 to 26 degrees Celsius only. Because water generally has higher specific capacity, and thus it will take a longer time to heat up or cool down. I give you a very good example actually. Hey, this was cool just now. You one shot down it.
Yeah.
Wow, okay. So imagine this is a cup of Milo, right? Okay, imagine it's a cup of Milo and it's hot, right? Usually, Milo, you have a spoon there, right? You stir it, right? It's damn hot, then you take out the spoon within maybe 3 seconds, your spoon is cool already. You can place it on your face here. But if you try to pour the Milo onto your face, what's gonna happen?
You're gonna die.
You're gonna GG out already, right? I mean, that's gonna be ridiculously dumb, right? But if you do that, right, you pour it onto your face,
That's third-degree burns right there. You are very
you need to call Batman already, because you'll be the villain already, at that point. Yeah. So why is it that? It's because water generally has a very high specific capacity. And because it has a very high specific capacity here, what happens is that it will be much harder to heat up. Once it's heated up, it's much harder to cool down. But the metal spoon that you place here, stir, right, generally has very low specific capacity. Stir, place it up, 3 seconds, you can touch your face with it already. Right, but if you do this, then it's GG. Okay, understand guys? Different materials have different specific capacities. The harder it is to heat up or cool down, the higher the specific capacity is. Okay. So, having said that, everyone understand this concept, Everyone understand, right? So, having said that, right?
Somehow this applicable to the thing we did last week.
Very good. So, generally, right, if you have a hand here, right? Oh shit, a poorly illustrated hand, but this is a hand. A hand,
It looks like
okay?
an antler, sir.
Or a leg, but it's a hand.
It looks like an antler.
It doesn't matter. Right, so
It just doesn't.
So what happens is, right,
Fingers.
because we have a layer of water here, right? A layer of water surrounding it, right? My God, it's good.
Hey, just let me draw. I'm just kidding.
We had a layer of water onto our hand, right? So what happens is, right, as soon as the fire that only burns for like 2-3 seconds maximum, all the heat that is generated will be absorbed by the water first. And the water will maximum increase by 1 or 2 degrees Celsius only. That's why we can put it on our hands. But if you're trying to be funny and you scoop like a damn big layer of the butane gas and you burn, right, you still burn your hand. Because the water can only absorb that much energy. The rest of it will be absorbed by your skin, which is obviously going to be damn hot.
So you sweat do the trick.
Sorry?
Sweat.
Yeah, sweat will actually help you prevent you from getting burned also.
Hey, that means my bad genetics finally can come to play already.
Mm.
You know understand?
But it's not going to help. It's not going to be, your sweat is not going to be faster than the amount of heat that
Then after like 1 second, it just like evaporates.
Yeah, because the water is less than the kg, so it can only absorb that much heat energy only. Right, because if you go back to here, right, 1 kg of water needs 4,200 joules to increase by 1 degree Celsius. That water that we layer onto our skin, right, it's not more than 1 kg. So even though it absorbs heat, it will not absorb that much heat. Yeah, I mean. Yes, very good. Okay, everyone understand this? This is the concept. Everyone understand the concept first. Now we go to the calculation. Specific capacity has a calculation of Q equals to mc theta. Remember this, Q is going to be your heat energy, which is measured in what units?
Joules.
Joules, yay. This M will represent your mass, which is in
kg.
kg, very good. Then your C will be your specific heat capacity. What units was it again? Just now I said. Okay, never mind. We skip the units here first. I'll teach you how to do it later on. And this is essentially your change in temperature, guys. The change in temperature, which is measured in what units? What's
Degrees Celsius.
Yeah, degrees Celsius. Now, this comes the fun part. Guys, in your exam, right, most of the time, hey, everyone pay attention. Everyone pay attention. This is a very important skill to have. In your exam, most of the time, you realize that, shit, forgot how to write the units for spring constant, specific capacity, some random thing that my teacher used to teach me, blah, 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 you forgot already. But it's okay. If you ever forget the units, for example, like this, you cannot remember the units, right? All you need to do is rearrange the whole formula into C as the subject. So in this case here, it will be C equals to Q over M theta, right? Right? And because of this, I know that Q is in joules and M will be in kg and theta will be in degrees Celsius. Based on this, I know that specific capacity is joules per kg degree Celsius. And this is how you recall the units for random things that you are not supposed to remember. Okay, you can derive it yourself from here. Understand? This is a very important concept, by the way. Okay. And the final thing I want to talk about before I give you guys the time to copy everything down and do the exercises that you see on the right side is basically defining what specific capacity is. Now, in your exam, they love to ask you this, when it comes to this kind of question, they ask you to define what specific capacity is. Do you know that as long as you can make this formula upwards, you can literally bullshit your way through the definition? Okay, I bullshit one time and show you, by definition, specific heat capacity is the amount of heat energy needed to change 1 kg of a substance by 1 degree Celsius. I'm going to ask you guys to repeat this. You better know how to say this. Specific heat capacity is the amount of energy needed to change 1 kg of a substance by 1 degree Celsius. Everyone understand this? You are going to be asked to bullshit. Anyone don't know or don't understand or want me to repeat, you better say now. Because if you don't say now and I call upon you, I'm going to...
The amount of heat energy required to heat 1 kg by 1 degree Celsius. What?
Yes. Okay, let me repeat. Listen up, everyone. It's just following the formula only. Specific capacity is the amount of heat energy needed to change 1 kg of a substance by 1 degree Celsius.
Yes.
One more time.
Specific heat capacity is the energy required to change 1 kg of mass
Of a substance?
of a substance by 1 degree Celsius.
Excellent, very good.
1 kilogram.
Kilometer is crazy.
1 kg of a substance by 1 degree Celsius. Okay? Understand? Okay, good. Starting with you. Tell me again how to define specific capacity. Specific heat capacity is the amount of energy needed to change 1 kg of a substance by
One.
degree Celsius. Next, you is defined as the one kg of a substance by. Very good. You next.
Specific capacity is the energy required to heat 1 kilogram of mass by 1
Celsius. 1 kilogram of a substance by 1 degree Celsius. And let's
heat capacity is the amount of energy 1 kg of a substance by 1 degree Celsius.
yes, but I was actually asking for you. Yes, very good. Next, you. Ming. How much? 1 kg of mass by 1 what? Wait, this one. 1 degree Celsius. Excellent, very good. Okay, your exam they'll ask you to write this, so you better know how to define it. Having said that, copy everything down and start attempting the 5 questions on the right. You'll notice that the 5 questions on your right, 4 of them is easy and question number 5 is hard. Let's see how many of you guys can solve questions 5. Probably reading down and attempt the 5 questions, right? Hey, which chapter are you going to do right now? Still talking about papers.
So I haven't even received my paper yet, you know. Because there's this woman, her name is Dr. Wong, she specifically she said, wow, this one 我最头痛我不要改先I wait until 10,000 years only I want to 改I graduate already in my funeral she gonna take my paper and burn it to the heaven and give it to me.
Assuming you die before her, so old already.
No, it's not that she's gonna come back as a spirit from the don't know where I'm not gonna say where she's gonna go.
She's waiting for you.
Hey, for real, that could be a possibility. She may Saint Peter and like Jesus like hello, here is your people. No, chemistry is a different story.
And Dr. Wong teach physics and chemistry.
Yeah, she is a jack of all trades, master of none.
I remember.
That's
You go copy it down.
Write
down the formulas, substitute each component one by one, and then find
that.
Yeah, it's not an formula. With that, yes, and you write it.
That's true. You have a point on. Jack of all trades, master of none. And go. No.
Okay, tell me what is it? What is the what is the so if I use M for M vehicle, but it's here. It's not very right, data, and the data looks better. But but when we involve the documents, we can start doing everyone thinking. But always write the formula, guys. If I walk around here and I see that you know the formula, I will read you first. Then I'll tell you to write the formula.
Wait, so specifically capacity is like the. Wait, hold on. Which one is it? It's the 400 to 100. The how many?
Units very good with one. This one.
Too much. We can do this.
Yeah, yeah. Cheap temperature, because I would temperature just big yeah. Yeah. What? What units? But like this is the actual value. Yeah, this is the actual value, but you do it's temperature very good. You read the question up. Is this read the question and tell me what you think is good. I think it's correct. It's correct. Why? Why? Yeah. It's not free. Wait, maybe it's not maybe. Because in this scenario, you know that the change in this
your questions to yourself is whether to change upwards or to change downwards for the reply which already was refrigerated. Okay, so if again, science ignore in this specific question, yes. Don't worry. Yung number will be the same say and out for which I can for now, yes, this is okay.
Wait, so.
I see that you have written down the formula for again.
I'm doing some
Question number 5, square the part sheet is the following. You can do question number 5 and get the correct answer. One bar. Question number 5.
Wait, that's some cup for.
Yes.
Yeah.
Please.
Yeah. Yes.
What about 1 5? What's that? Student. Negative, yeah. Mine negative 19, so. I don't know what I'm doing.
Why? What's so big?
Because I just took this times the 10,000, then I took this one times 3 so that is per kg ma. So my brain was like, this.
Yes. Highly recommend bringing your M calculator to the next week. Guys, question number 5, we're looking at solid what's out. Wait.
No, you get off. My life is
It's not as straightforward. But I do want to emphasize that if you cannot do question number 5, don't worry, they don't ask it like this in the exam. I just put it there to see you can do it.
So keep one out, I'll go in the same moment like that. Yes, you want and see the flavors. There's no temperature difference. Say that again. So it's okay for the biggest thing. Yeah. Yeah.
The whole is when there's no change in temperature, for example. Your fan is hot, boyfriend's hand is cooling, so this fan in a while, you do the same temperature after a while. That's called the clean sign.
Wait, so question 2
Yeah.
I don't
Ah.
understand. Question 2.
Nani?
My brain is frying, I don't understand.
Every week you tell me the same thing.
Because it's true, ma.
Becoming like more and more dumb like that way.
I'm being like the guy from Dumb and Dumber.
You label your information first, what's this?
This one is mass, right?
Oh,
Mass.
and this?
This one is temperature.
Yeah, it's temperature, but it's not change in temperature,
temperature.
right? And this one?
This one is the Q.
Oh, then this one?
This one is C, right?
Oh, so what are you looking for?
I mean, we're looking for theta. Oh, but how do I find theta?
Think about it.
Because I got 1,125 when I find theta. I am serious I am dead serious I got that usually 11.7 whatever time.
Wow, I think the full session.
Well, actually this guy like he just Starbucks class.
You're actually very close, man. But it's not very funny.
You haven't been taught. What?
That's cheating
It's not cheating, it's not cheating. It's not cheating. Speak line, follow the pattern. But we. But sorry,
when let me cook
is what? You like 1.5 Yeah. Thì gặp người tôi lên. So the change in temperature is coming in time, right? But I want to know the final temperature. And what is the temperature? 5 seconds. Yeah, I'm fine, man. Can go on. Further refrigerator. Hey, this. What's wrong? I just keep for zero. I don't know. Think about it.
Yeah. And yeah. So I think it's too natural for Starbucks to you.
Husband's cooking already. Okay, I get this. I'm buying one out.
Wow. So I feel like next time I like you have to say the word Starbucks multi it is man.
You yeah, I'm not use that temperature. This is what's temperatures to be all that. Right, you like to I don't get that. Huh? Yeah, yeah, okay. Right.
Hey, no swearing, no swearing.
Yeah. Almost story. Yeah, actually. Almost story. You know, this is actually very close. Yeah. So it's okay. I'm now. I'm studying because you're very close. So you can. So they. Oh, sorry.
我明白了。Just stop. Let me put my trust.
Cannot, those much because you see, you can see right. You're not falling. This right. Eventually, at some point, I'm going to see that picture. Like, I'm in that picture. So people walk away because this is one temperature of one thing. This is another temperature. I think you can understand that.
Wait, so by the way, can you tell us the answer? It's also you can reverse engineer it. Of course not. Last one we recorded. Wow, ChatGPT. Did I hear just hear ChatGPT?
They were cheating temperature, right? Because it's cheating temperature. Because starting temperature, this is cheating temperature. So they give more information and the problem. You know, give it like a later. I A and I think start with later. Yeah, okay. Ui, 做完不是提前啊，你们两个。
那太上了，我觉得。
全部不对。
这100 and hold on, not 100 it's lower than 100 Duncan. Give us a hint, give us a hint. So is it 40
No.
Maybe 52.
How can you make 40 or 1 times 5 so it's 40 add together become negative 40? I don't know. So,
Is it 100 110.
100 and then one lower than the original averages of both of them, one higher than the original averages of them. One is highest and highest really for you guys.
Wait, that means the hint that is in between it.
Wow, you're very close, man. You think about it, you're very close. She's the closest one already. Think about it. Close.
Hey Daniel, what do you use? Daniel, wow, how do you do it? How do you do it? I checked how do I do this? Mr. GPT. I not ready. I did the paper as Duncan I saw already. I will 不小心
So close. 下，你差不多了，下，你差不多了。做多一次，你我听。
It's giving me the balance, but it's not following it for me.
I was asking you something about you.
It just says based on taking the balance, okay, that's all it is.
And
Yeah. It's not really if you do it this way, you would get it, this shooting.
and Tia is all. Oh yeah. This one's Q, right?
Ah, Q.
So it's not Q, okay. My bad.
Well, guys, you have 5 to 100. Then after we go through the questions already. Since I see most of you guys, 哇，这全部进去哇，这都太少。Okay. No, do it. Read it.
What the? Wait, so why is specifically this question gives so hard one? I don't understand.
It's, I think
Oh, that means it's a high. It's somewhere like 20多度 or something like. I'm convinced like 20多度 now.
See. Something called. Okay.
last 5 minutes, guys.
When I go in, it's also very close, but it's wrong somewhere. One part of the equation is wrong. Yeah. No, how many this one starts at 95 and this one starts at 4. How can it after place two together become lower than originally done? Because you know, wasn't.
Oh, wait. Hold on. It's not over yet. It's not over yet.
Okay, now. You check the question properly. If you do it correctly, you can get the answer. Yeah.
Explain that. Oh, shit. Oh, shit. 第一个在
Yeah.
所以这个是对吧？
你要想，你想有95点跟140，两个加起来变成几？
太没劲了。
那个 oh, the original thing is not 90，它那个我是啥？
Duncan, I'll give anything. And what in your thing is the what? You know, can maybe you know the equation thing the
No.
what if we use simultaneous equation like you secretly don't tell us.
我拍啊。OK，你们复习这个。Leaving job, right? Let me explain the last question. I thought a lot of the questions were very close, but the main concern is that okay, 来，我们一起讲最后一题 okay, since everyone is very excited.
I'm not excited, I'm 加速啊 I mean damn 加速啊 I'm bringing
Very good job, Tanya. Excellent critical solving skills. Very good job. 下一个 Starbucks 啊，下一个礼拜。
加速的时候啊 how the hell do I
Okay, so the question starts off with something like this, right? It says that I have a metal ball that is 0.02 kg with a specific capacity of 450 joules per kg degree Celsius and starting off with 95 degrees Celsius. Then after that, I have water, which is 0.2 kg at 4,200 joules per kg degree Celsius. And it starts off at 24 degrees Celsius. For those who give me answer like 100 over or 20 something, doesn't make sense, right, bro? What fuck's going on actually? Can you put two items together and then suddenly boom, 100多 degrees Celsius? It's chemical reaction already, right? Right, and then or some of you guys that give me smaller than 24 degrees Celsius, what? Put two together, then suddenly all the heat starts dispersing outwards and the temperature cools down. Right, if logically thinking, the temperature will be between 95 and 24, right? Just like hey, listen to this dumb story, okay? 你的手25 degrees Celsius. 你女朋友的手27 degrees Celsius, hold each other your fireworks 100 degree temperature, 100 degree temperature, no eventually you're going to equilibrium which is in between 25 and 27 right? Makes sense right? So first and foremost you need to understand that if I place this thing into here, thermal equilibrium will occur in a sense that, can I say that if I place this metal ball into this water here, the amount of energy lost by the ball is equals to the amount of energy gained by the water. Does this make sense to you guys or not first?
No.
If I place this ball into this water, this ball is obviously going to lose energy, right? Because it's high temperature, right? And this ball is going to gain energy, right? So where does this ball lose the energy to? To the water, right? And where does this guy gain energy from? From the ball, right? So I say that the energy lost by the ball is the energy gained by the water. This is the first information. Then from there, I start substituting my information in law. MC theta of the ball would be MC theta.
Yeah, so I think your iPad is broken now.
No, it's a feature that
You can turn it off in the settings.
that I can turn on in the setting by.
Do it
Don't know how to do it now.
Just Google it
Okay, anyways, MC data equals to MC data. From here, substitute information in law. This is where it gets tricky, guys. 0.02 multiplied by 450 multiplied by the change in temperature. My idea is that the ball is going to increase or decrease in terms of temperature. It's going to decrease, right? So it should be 95 minus x, right?
Oh yeah, see,
Right.
you look at it, I
Then after that, the next part is different now. The next part is different now. Because right now it'll be 0.2 multiplied by 4,200. But I know this thing changed in temperature increase, right?
plus one.
No, it's not plus, it's x minus 24. Because at the end of the day, it's the change in temperature.
Oh my days.
Right or not? The final temperature of this thing is higher than 24 ma. I want to find the change in temperature with x minus 24 ah. Right.
Damn close,
Which is what she did. She was the only one. That's why I say you were close, you were close, you were close, and he was close also because some of you guys, I see you managed to do something like this, but swapped it around.
I must
Swapped it around. Right. Sadly.
Actually, if you do ChatGPT, you won't get anything
Yeah.
out.
But you have gotten the right answer lah. From here, it's just algebra law. Okay. So why this one is minus this? Why is number minus x minus number here? Is because number one, I know that the ball is going to decrease temperature, right? Decrease to how much I don't know, but I know that it's going to cool down, right? Because it cools down, right? I want to find what's the change in temperature from the initial temperature of 95 to the final temperature, which will be something lah. Will be x lah. Right, but this one here is x minus 24 is because the final temperature is going to be higher than 24. Right, I want to find out how much is the change in temperature of the final temperature, which is x, to the temperature right now, which is 24. That's why it's minus here. Here minus this because the temperature decreased. This thing minus 24 because the temperature increased.
So one thing you remember is x. If x minus is always increase, if the number of x is decrease.
Yeah, you could say it like that lah. Okay, then from here it's just algebra. Times, find all the x, find all the number, then at the end of the day, you'll get x equals to how much? What's how? Yay.
我想要死。
不要啦。Green place. Likes to look at so that. Yay, Udanya, yay. It's all smiley faces. And some jealous faces. Yay. Okay. Yes, but essentially that's that. Okay. Okay, everyone. If you no questions, everyone. Okay,
I'm ahead of.
but good attempt. So you guys are only motivated by Starbucks,
Yeah.
I'm gonna change every question, every one exercise to have one hard question and make you guys think for Starbucks.
So it's actually the main person who has the most motivation when it comes to Starbucks is the guy next to me.
Yeah, I know. He was very close. He was the first one to get very close.
Whenever free stuff comes out of the mouth, the first person who will grab the opportunity is you. My man was letting the shit out like the
For last question straight away.
he's gunning for the Starbucks, bro.
Okay, guys, check the answer for each one of these questions. I think most of you guys got it correct lah. Because it's 24.75 degrees Celsius. Do you get it? Very good. Wow. Because I didn't show the working, I just gave you the answer. I mean, if you do the algebra, you may get it wrong also. Okay. Guys, please check the answer for question 1 to 5 to 4.
I want to pack up and leave, man. This is so depressing.
Don't worry, bro. You already won the last round. Right, the last round was you, him, and her, right? Okay. Anyone has any questions from question 1 to 4 that anyone cannot do?
I will never leave down this failure.
Okay, everyone. Okay. Moving on. Or you copy? Yeah. Let me know when you're done. Oh, pass me my water, please.
Why?
Oh, what do you mean why?
Oh, I thought you said pass me your bottle. I heard wrong.
Drink
Huh?
drink
No, I thought you said to her, pass me your bottle.
I did pass me my bottle.
I thought you said that my 换去 your
Oh.
I thought you were trying to get her
Drink
bottle.
her water.
Yeah, for some reason I never felt I was thinking, bro, my brain was like, what? My brain was like dying, but I was like, I was like so confused. I was like, okay, what is this a Hamza kind of do?
Before I end the day, guys, last question, then you have 3 questions as homework, and then that's it for today.
Where?
Okay, so if you look at this last part here, we're basically converting electrical energy to heat energy. Okay, the most common example for converting electrical energy to heat energy is, imagine today, I have a metal cylinder here. One part of it is placed with the heater that is connected to a 3-pin plug. Right, this is a heater, by the way. And then another part is connected to a thermometer once again. Right. So how do I convert electrical energy, which is obviously from the 3-pin plug to this aluminum cylinder here, is by turning on the heater, right? So the electrical current is going to make this heater hot, which will eventually conduct heat to this aluminum cylinder here. From here, in terms of calculation, we need to ask ourselves, what's the general formula for power again? Power equals to energy over time, right? In this case here, energy would be equals to power times time, right? So from here, just now we learned heat energy was what formula again? Very good, it's MC theta, right? Would have been equals to power times time. So basically, if I want to make this thing to a specific temperature, right, I need to power it up for a certain amount of time, right, with a certain amount of mass, and I need to know the specific capacity of this aluminum block. Okay, sounds confusing, right? Don't worry, later on there will be exercise to explain much more on this. But essentially, this is the calculation to convert electrical energy into heat energy. I need electrical power from the source, right? And it must heat it for a certain amount of time. And this aluminum block must be a certain amount of mass with a certain amount of specific capacity for it to finally change temperature. Okay, this is essentially a quick way to convert electrical energy to heat energy. Okay, everyone? Ratio, no, just mathematics only.
Ratio separation.
Huh?
Oh, no,
Ratio. No, this one, don't worry. Okay, copy this formula down first, and then you start attempting the questions at the bottom.
What time is it now?
Finish at least question number 1, then I'll let you guys go. Do question 2 and 3 at home.
I want to. Oh, out of spite, I'm gonna go drive through Starbucks later.
Fine. But it does feel a little bit hot today, though.
Cause mine is damn hot, so yeah.
Yeah.
哎，你们去扫墓了吗？
That's like literally the best is 1 though. Oh, no wonder I can't even hear it fine. Olivia, Jenny,谁回家？Olivia，
然后呢？
千羽啊，
No, I mean it's isn't that too early, yes now.
哦，假期，假期会中国是啊，假期会中国是啊。
应该吧？
OK，没关系。
好过没有啊？
Okay, do question number 1 and I'll let you guys go. Finish it and then I'll let you guys go. That will be the end for today.
What are you watching It sounds very interesting. What are you watching
I'm watching this China guy that sells lightning.
Does he like sell crack in the street or something?
No.
Like Q can be equals to PT, right? So
Sorry?
if MC theta can be equals to PT, it means Q can also be
Yeah,
equals to PT,
yeah.
right? Or PT equals to Q. 这样子可以吗? Like how to say also? Means you're trying to find energy, right?
Yeah.
Then it kind of just like say power times time 15 seconds.
Yeah,
Right?
it is.
这样子报啊?
Yeah.
Wow, eh.
Don't overcomplicate things. Physics is easy.
Isn't physics the most like complicated one?
Nope.
What is?
I would say biology is the most annoying because it's pure memory. Chemistry is also very annoying because a lot of memory and some application. Physics is mostly application and very little memory.
What is the increase in temperature of the metal block after 15 seconds of power supply? You see some. Now what? I don't know.
Units and formula.
Now,
So
this
this
is just PT.
Sorry, what do you say? Why 30? No, it's still 15 seconds. What is the increase in temperature? Right now, you need to find the what component? MC, data, power, time? Which one? C? What are you looking for? Oh, you're looking for data, right? So you write down the formula and you find one by one. What do you need? You need data.
It's something minus T. How to find? You done question one already. I'm good. Just 400 times 15 now.
Okay, everyone, anyone not done with question number 1? Check the answers, guys. You're supposed to get 6,000 joules and 6 degrees Celsius.
Wait, how do you get 6 only?
What?
I also got 6 only.
6 degrees Celsius.
Yeah, 6 degrees Celsius.
What? 6 joules?
So I got 6
How do you get 6 joules?
I got 6 degrees Celsius.
Yeah, good. How do you get 6 joules?
maybe it's like
Yeah, it definitely is like because the formula you should be using is
Power times time.
PT equals to MC theta.
2.5.
Where you got over? No need over. The first one is
Can you put myself?
you finding energy, right? Energy
myself-
equals to power times time. 什么鬼？
不你跟什么来我，这个不是打，这个不是 energy 了哦。What you are doing
I can't see the difference because I have the Michael Jackson eyes, bro. I see black and white as well.
你这个话 energy equals to power times time divided by m data. 可以这样子写的吗？ How do you even get this here? It's either energy equals to MC data or power or energy equals to power times time, right? You can if you do like that, power times time equals to MC theta. You did power times time equals to M theta, right? You're looking for C already, hello.
Oh.
Make sense or not? Oi? Okay, everyone, please continue to do question number 2 and 3 as your only homework this week. Next week, we'll continue with the chapter and then we'll be attempting some past year papers together. Huh?
1 billion.
1 million. 6 degrees Celsius. Okay. See.
We tell why.
Goodbye.
What is it? What? What? Okay, again. What's my there? I don't know how about